All right, as part of an extension of understanding the lone pairs is our arrow pushing. And then this is a big part of organic chemistry, probably my favorite part of organic chemistry, and really kind of what makes me feel like a chemist is not just understanding that reactions happen, but understanding the how and why. And that's what OChem is kind of really about. So we'll put understanding of how slash why chemical reactions occur. And of course, if you understand how and why something occurs, then you can make predictions. And when you can make predictions, you can make new novel things and all kinds of really exciting things that we try to understand in the hopes of being able to predict. So when it comes to chemistry, and here I'm talking about non-nuclear chemistry, electrons basically do the things, right? Electrons are the action guys. They're the ones that actually do stuff. So electrons do the things. The nuclei are kind of along for the ride. And our electrons come in two main sources. They either come from bonds. And remember, a bond is made up out of two electrons. And then they also come in lone pairs. Right? And then those are also two electrons. And so these electrons move around, they reorganize, they form bonds, they create bonds, they destroy bonds, that kind of thing. And we demonstrate how they do that through these arrows. So our arrows show the movement of electrons. And there's two main ways that we show arrow pushing diagrams or movement of electrons, and that's either in reactions and resonance structures. In reactions, we actually are showing the true flow of electrons, right? Electrons are moving, they are creating bonds, they are breaking bonds, that kind of thing. In resonance structures, they're more just so hypothetical. Right? There's only one real structure, and we draw different resonance structures to help demonstrate what the real thing looks like, because in real life, it's a little bit more complicated than just a bunch of lines and letters. So we really need to get good at arrow pushing. We're going to spend probably about 2/3 of the course on arrow pushing. It's something that you should have done a lot in first semester organic chemistry, and we really want to master this skill. And so the tip here is slow down and follow your arrows. Think about like, being back in, kindergarten or whenever, and you're trying to learn how to read, really slow down and understand how to pronounce those letters, understand what each arrow is doing, and where it's starting, where it's ending, that kind of thing. So the questions that you kind of want to ask yourself when you're reading these diagrams is what bond is broken? Maybe there's more than one. And then the other thing that we want to understand is what bonds are formed. And then what comes with that is also we need to think about the charge, right? And in organic chemistry, we don't see too many charges. We'll generally only see +1, 0, or -1, right? Those are the three main charges of our compounds. And they're going to only move in one increment at a time. So if you see a compound that has a +1 charge, then maybe it'll go to 0 if it gains electrons. If you see a compound that has a neutral charge, no charge, maybe it'll go to +1 or maybe it'll go to -1. And then if it has a negative charge, maybe it'll go from -1 to 0. But we're never going to hop all the way to the other side, right? We're not going to go from +1 to -1 or anything like that, right? It's only going to move in increments of 1. And then our arrows look something like this, where we have a tail end and a head end. So the tail end is where the electron pair starts. And then the head of the arrow is where the electron pair ends. And next up, we'll take a look at what that means exactly.